So good morning and good afternoon. I hope you're doing well at whatever time it is for you. And I'm delighted to welcome you to this workshop on scaling up and industrial transition to bioeconomy, part of the Global Bioeconomy Summit 2020. My name is Tatjana Schwaber-Markovic. I'm Senior Project Manager at CLIB, the Cluster Industrial Biotechnology in Germany. And here I represent the 3BI Intercluster, part of the organizing team. I will guide you through the presentations by representatives from established industry and dedicated bio-based companies, and I'm looking forward to seeing you all engage in the breakout session later on. We'll start with words of welcome from the organizers and a bit of scene setting by them. I will then call on the speakers to give their input presentations, and after all the presentations, we will have time for a Q&A session. And you, the audience, can ask questions via the chat box, which should be on the left-hand side of your screen, next to all the participant names, and maybe someone is typing in a hello right now. We've already seen some good mornings flying in. And you can use that box as you've already started to do, to say hello, to interact, and also to ask your questions or provide comments. We would ask you to start your questions with 3 question marks so that we can find them more easily in the chat. And please do stay muted during the workshop and don't close this tab, otherwise you will be disconnected from the meeting and it might be difficult to get you back in. And with this, at the outcome of the workshop, we'll produce a short video and a presentation with the guiding questions and outcomes. And both will be shown in the panel session of the Global Bioeconomy Summit on Thursday. We will also follow up with a report. So all your comments will be read and appreciated, and they will serve us to draw up these conclusions. And now I would ask Dr. Sarah Hickinbottom, CEO of BioVale in the UK, and also a representative of 3BI, to unmute herself. And I can hand over so she can welcome you. There you are. Hi, Sarah.
Hi, Tatiana. Thank you. I don't have slide sharing yet, so if you could move the slide forward, that would be great.
I will. This is just the organizers again and the agenda. And there.
Brilliant. So if you stay on board, oh yes, I have slide sharing now. That's awesome. So morning, everybody, afternoon. It's fantastic to be here. I'm going to dive straight in. 3BI, we have co-organized this workshop along with the Advisory Council. But who are 3BI? Why are we organizing such a workshop? Well, as you can see from this slide, we are Europe's bioeconomy intercluster. We're a partnership between the Bioeconomy Cluster, BioVale, Circular Biobase Delta, CLIB, and IAR. And our name says it all. We broker bio-based innovation. So apologies for the map not quite looking right, but what it shows is that we are across Germany, the Netherlands, France, and the UK. And we build on the complementary strengths of our 5 regional innovation clusters. Now, these slides will be made available post the event, so you can take a time. I'm not going to read these through, but effectively what our goal is to broker, accelerate, and foster collaboration and innovation. So as you can see from this slide, which outlines goals and ambitions, it is to build those scientific commercial partnerships. It's to facilitate research, innovation, scale up, and ultimately that is to accelerate commercialization. The point of our workshop today is about that absolutely crucial industrialization and acceleration. So I thought it was quite useful to actually outline the fact, why on earth would 3BI be necessary? In fact, why on earth is a regional cluster necessary? What are we? Well, partnerships, as you can see from this slide, which outlines the UN SDG goal number 17, we are at the crux of how to build a disruptive industry, a bio-based industry. And it's useful to take one step back to remember that not only are we all taking new innovation, new technologies, and creating something, that we're doing it against a backdrop of a time in human history with absolutely mind-blowing scale of change. We have macro trends like electrification, digitalization, the Internet of Things, AI, 3D printing. We have a global finance industry that is pivoting at a speed to impact investing and to see how capital can be used for good. We have resources and climate, and throw in a pandemic. And we also have circularity, whereby we are increasingly seeing what our ancestors knew, that waste is a resource. So to achieve, to harness, to leverage, to face all of that, we have to work together to flex a bioeconomy muscle. I've put an African proverb on this slide. If you want to go fast, go alone. If you want to go far, go together. And that's what 3BI and our regional clusters do. We are driving collaboration in order to achieve the scale up that the workshop here today is about. We focus on the exchange of knowledge and ideas, trust, and absolutely crucially, ambition. We have to be bold. It's useful to note that all of us are members of the Bio-Based Industrial Consortium, BIC, Europe's private arm of our public-private partnership, BBIJU, which has funded a lot of the innovation you will see at scale from today's workshop. And under Horizon Europe over the next decade will reimagine itself as the circular bio-based economy. So our contact details are on the next slide for your, your information. You can find us on websites as well. And I want to say, do contact us, work with us, join us. It's what we're here for. And it's my absolute pleasure on that note to ask my colleague who's in Japan, what time is it, Yoshi? If you would like to say a few words before we kick off. So Yoshi, if you could at least activate your audio.
Yes, I think it is on.
Fantastic. I'm going to move over the slide. Oh no, I think you have slides as well.
Well, now can you do? So here I am.
Yoshi.
So yes, this is Yoshi from Japan. I'm one of the International Advisory Council member, and together with Mary Maxon of United States and Vladimir Popov of Russia, we have been designing how the Bioeconomy Summit should be and how the breakout sessions should be. And we sort of came up to a conclusion that industry's commitment is one real key issue for enabling bioeconomy forward. But it's not easy to, or it's not always successful to start or convert bioeconomy style business from traditional style business. So what actually is it? Are we lacking technology or funding or market structure or regulation or insufficient value chain or inadequate public awareness? In any way, we want to find out what would be the common denominator for successful realization of bioeconomy. And we would like to not shift to a stable bio-business conduct, not only depending on the subsidies or funding from outside source, but make this a normal style business as bioeconomy. So I will hand it back to Tatiana. Thank you very much.
Yes, excellent. Thank you very much, Professor Yoshiyuki Fujishima. Indeed, we have a packed agenda, and it was a lot of fun and work bringing it all together, trying to marry the two sides, if you will, of large-scale industry shifting away from fossil and dedicated bio-based companies entering the market with their bio-based products. And these are the following presentations. This is what they're all about. And I would immediately draw on our first speaker. That is Luis Cascayo Pereira. He's technology leader at Dupont Nutrition and Biosciences and should be coming to us from far away California, where it's late at night. His presentation is already there. Luis, can you unmute yourself?
Yes, Tatiana, can you hear me? And can you see me?
I can hear you well. I can't see. Yes, now I can see you as well. So if you can control the slides, then the floor is yours.
Thank you very much. Good morning and or good evening to everybody wherever you are. It's a pleasure to be here, and I really want to start by thanking the organizers for the opportunity to have Dupont share a little bit of our experiences here today. I am Luis Casquillo Pereira. I'm in Palo Alto here in California, and I lead technology programs at the Nutrition and Biosciences Division of Dupont. So my challenge here is to use 8 minutes to go over some of the key learnings that we arrived at in biotechnology from the last 200 years, a long history of Dupont. I want to start by showing the state of the bioeconomy. It is a reality. This photo here, this is our joint venture with Tate and Lyle to produce 1,3-propanediol. I'm going to talk about this example today. This is one of the largest biomaterial producing plants in the world, and it's been in operation for several years, and it continues to expand. So the bioeconomy is definitely a reality. We're strong, and let's look at some learnings and successes from this. I advanced the slides, so hopefully this is all working. A lot that I could say about an introduction to Dupont, but with the time, all I want to do is highlight our mission. Our mission is here. We want to empower the world with the essential innovations to thrive. We choose to pick important problems, many of them in the Sustainable Development Goals that Sarah showed. We align with those. We want to bring our science to have an impact on these problems and to advance our communities, advance our customers, our employees, and shareholders. So let's look at the long history of Dupont. It's a company that's been around for more than 200 years. It started as a explosives company in the 1800s. And for the first 100 years, that's what it did, essentially explosives of all types, gunpowder, dynamite, TNT. Around 1900, so for the second part of it, it created the experimental station, the first corporate R&D lab where you can have scientists and engineers working side by side. And it really started using the waste of explosives and created an industry in polymers and plastics. Many of the innovations you certainly know, nylon, Teflon, Lycra, spandex, and Tyvek, and so forth. Very thriving business. Fantastic innovations there, Nobel Prizes coming out of the research and the products developed by Dupont. And how did this company, how did Dupont move into biology? The oil crisis in the late 70s and 80s was a big wake-up call. Dupont reacted to that in two ways. First, by merging with Conoco at the time, the largest merger of two companies, and basically started operating refineries. So securing access to carbon in order to continue its businesses. Dupont operated more than 20 refineries at one point. The second reaction was, well, maybe the company should diversify a little bit and look at new businesses where science plays a role. That's something that we do well. It's in our DNA. And one of those new types of businesses was biotechnology. Dupont started working into pharmaceuticals. It even had a JV with Merck, but several drug products out. And it got into agricultural, with the acquisition of Pioneer, doing genetically engineered seeds and combining with crop pesticides. A lot of exposure here to biotechnology, and ultimately Dupont came to realize that could also use biotechnology to secure carbon for all of its businesses, for polymers and so forth, instead of relying on oil, but basically work on renewable sources here, crops, sugar, and break them down into the precursor chemical blocks required to build those polymers, build those biomaterials, those bioactives, and even biofuels. Some of the key learnings that we have arrived at after putting products like these on the market is sustainability alone is not enough. Customers have come to expect that sustainability will be part of the value proposition, especially if you are using biotechnology. But if you really want to have impact, if you want to be able to go from maybe that 10% or 15% of the market maybe folks here in the San Francisco Bay Area and other parts of the world who are willing to pay a premium for sustainability. If you really want to have a lot of impact and reach 70, 80% of the market, you need to hit the sweet spot. And the sweet spot here is demonstrated sustainability benefits, for sure, but also at the right cost. The economics, they have to be there, ideally at the same price, if not lower. But really competing on performance, providing something that people already have, it's tough, but if you provide them with something unique, you know, that's better, then you really get them to adopt and the impact is high. So one example of that is BioPDO. This is the producing the plant that I showed in the first slide. Basically, here we taught a bacteria to produce a precursor chemical used in a polymer. This process was known to produce this polymer 3GT through a chemical route. And being able to train this bacteria and tour de force in the science to mutate it and get it to produce these precursor molecules, you can make a version of this process now where a good chunk of it, about 40%, is from a biological route, but it's you know, less energy intensive, a lot less greenhouse gas emissions, and it makes a very interesting polymer that's got some unique properties. This development took a very long time. This is basically something that started in 1994 with basic research done by Dupont, and it took all the way into 2007 for the plant to start and be producing it. What I want to emphasize here is that partnerships are key. Sarah mentioned partnerships earlier on. I completely agree. I actually came to Dupont through the acquisition of Genencor, one of the companies shown here on this slide. This was at the time a small biotech startup. They had some really useful technology, what we call metabolic engineering, to help program this bacteria. And Dupont had a lot in biosciences already and processing, and so did Tate & Lyle, a lot of capability. But you have these very large companies and very well funded realizing that you still need a partner to get this done. You need to go find people who have capability that's complementary because the problem is just too big. So this is what went on. You know, the product was developed. There was a specific product in mind to create a fiber that could be used to make carpets, for instance, and that's what's shown here in the slide. Mohawk, you can buy this in the United States at a Home Depot. It's got a very nice and silky feel to it. It's got a unique texture. That was the first application, but then many more continue to come up. So you think you're starting going after a product, but you're really developing a platform. And we put this product in cosmetics, airplanes. It is in the dashboards of Toyota cars. And we're even working here with Stella McCartney to make fur alternatives that don't use animals. So you never quite know where it's going to go, but something that's got the potential to become a platform is probably something you want to bet on because the investment is very high and it's very capital intensive. So what's the future here? You know, I like to show this slide with these three bubbles. You see here on the left, petroleum-based polymers, you know, you can customize them quite a bit. They can be made pure, but they're definitely not recyclable. They're not renewable. They're not the best thing for the planet. On the other end, on the right, you have biopolymers extracted from plants. Cotton is a great example. There's limited functionality of what you can do. It is a renewable resource, not always pure. Where we are headed is instead of now trying to mimic what we could do with polymer chemistry using biology, we're really in the middle here. We are engineering biopolymers. We're making them out of sugar or these precursor building blocks to create better polymers than what we could do with petroleum, with unique capability that meet all three of these criteria: functionality, purity, and renewable. So I'm a little bit ahead, but I just want to leave you with this slide. You know, we're working with companies big and small to turn these things into a reality, and I look forward to answering some questions. Thank you very much.
Okay, thank you very much, Luis. We will collect questions in the chat to then pose them to all of you at the end. And thank you for explaining the history and the decisions behind DuPont's move towards biotechnology. You showed an awfully small spot in that sweet spot in that overlapping Venn diagram, and I'm glad that you managed to hit it with your product and showing that bioeconomy is already a reality and it'll be important to expand it further. I think expanding it further is what our next presenter will show to us. It's Babette Petterson. She's VP Europe at LanzaTech, and I already see her slides. Can we hear you?
Yes, can you hear me, Tatiana?
Yes, I can hear you well, and your video should be up in a moment as well. There you are. Okay, go ahead, Babette.
See if I can move the slides. Thank you. Good morning, everyone. And Tatiana and the organizers, thank you for the opportunity to present here today. As I think was just said, now for something different. Listening to Lewis, 2 decades of DuPont, and starting with dynamite, I'm going to be talking about LanzaTech, which is only 15 years old and started with biology. I'm based in Brussels, so we're also moving across the world, and joined LanzaTech in February of this year as Vice President of Europe to help accelerate our business growth. So I'm going to talk a little bit, just to set the stage, about who we are, for those of you who are not familiar with LanzaTech. As I said, an early stage small company, 15 years old, founded in New Zealand. And what do? We recycle carbon from waste, effectively from industrial emissions, from pollution to make fuels and chemicals, and to contribute to a low carbon economy. On the right-hand side, as you can see from our investors, we have a global, not only a global presence, but also global investors, and are already operating at commercial scale in China. What specifically do we do? And again, a little bit familiar with what you heard from Lewis. We engineer biology. Synthetic biology is the core of what we do, and that's right in the middle of this slide here, as you can see, in the bioreactor, using gas fermentation. And we effectively, these microbes convert carbon-rich gases, whether from off-gases from steel, syngas from municipal solid waste, or biomass, into different products. And as you can see on the right-hand side there, we started out with road transport fuels, aviation fuels, and on the bottom right-hand side, we're building on that to move into chemicals and polymers. So we actually built the first plant within the first 10 years of the company. This is our commercial plant in China. As you all know, they say that the valley of death is to get to commercial scale, probably more like the Grand Canyon. But through more of a distributed model, and to the topic of scaling up an industrial transition to the bioeconomy, I think what we found is that using a distributed model with smaller plants, multiple locations, helps build resilience and balance risk. And so this is our first plant in China. We've been operating there since the middle of 2018. And while there's only 17,000 tons of ethanol that have been produced there, we've actually mitigated, as you can see on that screen, close to 100,000 tons of CO2. And at the same time, we're building a plant here in Europe, in Ghent, in Belgium, that will be just over 60,000 tons of ethanol, again, on the chemical scale, not a large plant. And as you can see here, in another part of the world, in Japan, have been working with Sekisui to develop the technology to convert the carbon from municipal solid waste to ethanol, which they have then partnered with Sumitomo Chemical to manufacture polyolefins from this recycled waste. So again, just to give some examples of multiple smaller plants that we have been able to build, because of course investment is a hurdle, but it does make it somewhat easier if the plants aren't so large to start off with and are in different parts of the world. So to do this at the same time, we established a foundation. That foundation was ethanol, which for us was the building block of our short-term future in any case. And we moved that into really 2 markets. On the left-hand side, sustainable aviation fuel. That's our CEO, Jennifer Holmgren, with Richard Branson. We actually flew a commercial flight with Virgin Atlantic from Orlando to London using our sustainable aviation fuel. To Lewis's point, on the bottom right, on the bottom left there, what you can also see, many, many companies. We did not do this alone, obviously partnered with many different players to get to that point. And on the right-hand side, it moved into chemicals and polymers to broaden the base and balance the risk. Quickly run through some of these projects. One of the keys here has been we spun off a company called LanzaJet in the middle of this year, and we're using a new financial model where basically we got the investors to commit to, and you can see them here, commit to not just funding for the demonstration facility, but also giving a commitment. So this is a new financing structure to help scale up an industrial transition, that there is a commitment from these investors in commercial scale up once the milestones have been achieved. On the product side, some of you may have seen the recent announcement about a polyethylene bottle that L'Oréal have produced using carbon that's recycled by LanzaTech and converted from ethanol to polyethylene for this purpose. So again, I think in terms of early stage transitions, we have tried to create optionality by multiple applications to balance out the risk. Also polyester, we're producing MEG from carbon smart ethanol with partners, which other partners are transforming to polyester, and both bottles and yarns, fibers have been made from this carbon smart polyester. And most recent announcement was basically that our recycled carbon was used for household cleaning products in Switzerland, the Micro brand, where you can actually see for the first time here that the labels do state where the source of the carbon is from. So bottom line, I think the message here is we have tried to rethink how we scale smaller plants, multiple locations to build resilience and to provide optional flexibility for our partners. So it's really more about numbering up, we call it, than scaling up. Contrary to traditional processes that scale up big at a start, typical chemical processes, we've seen that for biotechnology, it can be different. More smaller plants and distributed plants, which allows us to get to more places and to more people, which will ultimately be more resilient. So thank you very much for your time. I hope this has been a little example of how a small company can grow and build from the start using bioeconomy. Thank you.
Thank you very much, Babette. It's an excellent example, I think, of how to overcome the valley of death and realizing smaller plants in multiple locations and spreading the risk, building up resilience is surely a very valuable asset, especially in these times when you can't depend on your one value chain to pull through, depending on where COVID strikes next. As an aside, if I'm permitted, we had heard that partnerships are important. And I remember that about 8 years ago, it was at CLIB, in fact, that we introduced LanzaTech and Siemens, leading to one of the first investments, which of course by now is not mentioned anymore, as it should not be, because you have since soared and made partnerships with many other companies that have been even bigger. But it's nice to know that there is a tiny, tiny bit at the very beginning that we also could help along with. So it's especially nice to see the company grow in so many different places and yeah, scaling up to the markets and mitigating CO2 emissions. Thank you very much.
Every partner has, of course, contributed.
We will now move across the world again to Japan, where our next speaker is Daisuke Kanazawa. He's General Manager of the Circular Economy Department at Mitsubishi Chemical. I see his presentation on the screen already, and his video is coming up.
Okay, thank you very much.
Yes.
Can you hear me?
Yes, so, we can hear you well.
First of all, I wanted to thank the organizers for having me here today. Today, I'm going to talk about the bio-based plastics from the viewpoint of the circular economy for plastics. Circular economy, that's because my name is Daisuke Kanazawa and I'm from Circular Economy Department at Mitsubishi Chemical Corporation. So a brief introduction to Mitsubishi Chemical. Mitsubishi Chemical is a diversified chemical manufacturer, and we make basic chemicals as well as plastic using those chemicals and the other functional products. And if you could take a look at the right-hand top corner, it says carbon chemical. This is used to be called petrochemical division, for example. But we stopped calling that division petrochemical because the feedstock, the raw material, is not going to be petroleum only. So we're going to be using bio-based materials as well as recycled materials. So we changed our business name. And we also make polymers, plastics, and some of that is bio-based or biodegradable. And I'll talk more about that later. So these are the markets, 5 main markets that we serve. They are automotives, IT, display, electronics, medical, food, bio, and environment, energy, and packaging, label, films. And this is what we call the technology platform. We have a different technology platform, for example, catalyst, organic chemicals, inorganic materials, and of course, biotechnology. And we use these technologies to work on the film and fiber, composite, molding. And those technologies are supported by the material design and characteristics and so on. And combining this slide and the previous slide, it will look like this. So for example, if we take a look at the packaging and labels industry, we serve this market by utilizing these pieces of technology. We serve the environment and energy market by utilizing these pieces of technology. So we picture ourselves as like a company with a large number of drawers packed with different technologies, and we serve different markets utilizing a different sets of technologies. So moving on to the next slide. Back in 2007, Mitsubishi Chemical set sustainability as one of the pillars of our businesses. And since 2011, we incorporated management of sustainability as one of how we measure our businesses. So if we look at this is a 3-dimensional XYZ axis. So we evaluate our business in terms of profitability, that's management of economics, and what kind of advances we make in terms of technology, that's management of technology, and management of sustainability, what kind of advances we made in terms of sustainability. And we measure our businesses in combining these 3 factors. And if we take bioplastics. Before that, let me talk about the circular economy. So today, plastics is considered a threat to the environment. But if we manufacture and if the plastic is used and recycled in a responsible manner, we believe that plastic will make our life better. So what does it mean by responsible manufacturing? That means we look carefully at the raw material, what kind of raw material we use, as well as emit as little carbon dioxide as possible while manufacturing. Use basically means functionality as well as longer life. And we make sure that the plastics are recycled properly. And if we look at the raw material, one of the examples is going to be bio-based raw material. And in terms of the bio-based plastics, here we have 2 axes. One is the vertical axis, and that means whether the feedstock is fossil-based or bio-based. And the x-axis is whether the plastic is durable or degradable, biodegradable or marine degradable. And in this map, most of the plastic today fall into this section, durable and fossil-based. In terms of bio-based plastics, we have products in this section, and I'm going to talk about this one first, and then we have a product in this section. So first, the bio-based and biodegradable. And next is the bio-based and durable. So let's look at the bio-based and biodegradable. So bio-PBS is not only bio-based and not only biodegradable, but it's as a plastic, it's easy to process, it's easy to heat seal, and compatible with many other plastics. And it's being adopted in a number of applications, but the reality is it took us well more than 10 years since the time of the R&D start and the commercialization. So it took us a long time to get to here. Another example is the durable bio-based plastic. It's called DuraBio, and we consider it as a glass substitute. It's a well-balanced performance as opposed to polycarbonate and acrylic. So it's got excellent scratch resistance and the coloring property, and also in terms of the for use in the optical films, it's got great transparency and less low optical distortion. So these are some plastics with that are bio-based, and has great performances or unique performances. If we so now moving on to the next slide, let me take one step back and look at the circular economy again in terms of plastic. So today the flow of plastic looks like this. Most of the plastic is produced today using fossil-based material, and most go into either landfill or incineration. And very little is recycled back into plastic or recycled as carbon. What we like to see as future looks more like this. So very little goes to waste, and actually very little comes from fossil, but a lot more is recycled back as plastic, and a lot more is if the plastic has to be incinerated, it gets recycled as carbon. And some of that is bio-based, plant-based raw material, and some of that is carbon capture and utilization. And if we take a closer look at this central section, it will look at like this, and this is going to be my last slide. So plastic production today can take different sources as raw material. So it could be fossil-based, it could be plant-based, or it could be carbon capture and utilization. And also it could come from recycled material. So in that sense, bio-based material is competing against the recycled materials and the carbon capture and utilization. And some of the key hurdles that we ran into, or we are running into still today, is one is if we want to expand the variety and the volume of the bio-based plastics, volume is one thing, but the variety is another thing. And the one quick approach we believe is the mass balanced approach, the adoption of a mass balanced approach. It's being adopted in Europe, but not quite in Japan. So that's one way we are looking into. And another issue is obviously the increased cost, especially at the beginning when the production volume is small. You need an investment in R&D, you need a capital investment in production equipment. And at the beginning, the quantity is low, the price is high. If the price is high, the demand is low, and that drives the price high. So to get out of the chicken and egg situation, that's, we believe, a challenge. And also we buy raw materials, plant-based raw materials, as a starting material for plastics. And we want to make sure that it doesn't compete with food. But the definition of food competition really varies. There are a wide range of gray area. And once we start the production, we don't want to change raw materials because different raw materials have different impurities, and that affects the polymer production. So we consider these are some of the major hurdles as we expanded the bio-based production. This is all from me. Thank you very much.
Thank you very much, Daisuke, for presenting how a large company like Mitsubishi Chemical can draw on its knowledge base and different technology platforms to then realize new sustainable value propositions, but also that it needs the patience to take a decade to produce a new product, and for already foreshadowing some of the discussion points we will surely touch on later on, the complications of scale, how to reach scale, and also the non-food competition issue, which is continually coming up every few years, I think, as a discussion point. So thank you very much. And we'll move to the next speaker, which is Nicolas Sordet. He is Chief Executive Officer of the French company Afiren. And I'm waiting to see, I think his webcam is switching on. Nicolas, do you want to start explaining a bit about what Afiren does and maybe also your recent change? I heard that you used to be in the finance sector.
Yeah, I used to be. It was in the finance sector, and it was. It's a big change for me. But to be honest, this is something I really wanted to do. Just trying to improve the actual situation. So first of all, thanks a lot for your help, and sorry for the invitation, and to give me the opportunity to present Afiren. We are a French startup, and in few words, maybe I can start without the slides anyway. It's a little bit common, but we have we say that we have two major issue to tackle. The first one is the global warming, and the second one is the fact we have limited resources. Then in the future will push us to find innovations to replace, and mainly the oil. And it looks to be common, but when you have to put everything together to find a new technology and a new approach, it's quite challenging. So at Afiren, we have tried to set up a solution to tackle those two main issues, to replace the oil on the non-renewable resources, but also to decrease the environmental impacts on the CO2 emissions. So to do that, Afiren, we have developed a technology, and we are in the middle of the value chain. The idea is to, through our technology, give an opportunity to the industrial, from the agro-industry, to valorize their byproducts and give them a way to be treated, actually. On the other side of the value chain, be able to provide to our clients, which are big industrial from a lot of different applications, from the food industry to the feed industry, or sustainable and 100% bio-based products. So the idea for Afiren was to replace the oil to produce some molecules, but with a sustainable, and more than that, a very strong circular economy approach, and I will develop. But at Afiren, through our technology, which is at the beginning, so maybe we can go in the slide. I can see the presentation now. Excellent. Can you also control it? No, I can't. So the idea for Afiren is we have a double approach. The first one is a fermentation approach, which is non-GMO, and I think it was explained a little bit before as well in the previous presentation. We made the choice to use non-food biomass as raw material. And here, for the first plant that we will build up, and I will explain, we've decided to use the sugar industry byproducts. The idea was, as I said, not to compete with food, human food, and we have non-GMO fermentation, which is very important as well. I will say that later on the application that we will target. And the idea after, with our fermentation approach and purification approach, is to be able to produce a 100% portfolio of organic acid. Today, those acids, from the acetic to the caproic acid, they are 99% based from petrol, from oil. So the idea was to bring something which is very well used and well spread, but pretty new with a new approach. Maybe the next slide. So which application for those molecules and for those bio acids? It was a little bit challenging at the beginning because we are a startup, so we were pretty small. And as we have 7 different products, We have a lot of different applications from the food, the feed, but also the pharmaceutical, the industrial chemicals are. We are producing as well some lubricants. I mean, it's pretty wide, and it was a big challenge at the beginning, but we've managed to understand a little bit more the application, the volumes, the pricing, the players. On globally, it's a very big market. Our acids represent globally around 15 billion sales per year on the world. On the idea with our acid, it's building blocks that we can derivate those acids into further molecules. Next slide, yeah. But the bio-based approach is very important, and we saw a big change from the beginning where our customers were looking for bio-based, but it's not only bio-based. We need to be as well sustainable, and we need to reduce our impact on the environment. And this is how we have settled and we have built up our process. And we have a circular economy approach because we will use some raw material, which is biomass, to produce our acid. And at the end, we will have a residue, which are very high value fertilizer that will come back to the ground to make a new biomass production cycle. So we don't have any waste. We are completely circular economy. And then on the other side, we will reduce drastically the CO2 emissions compared with the oil-based acids today. And we will divide that by 3, which represents around 20,000 tons per year of CO2, which is much more than the CO2 that the plant will emit. So yes, at the end, we are, as we said, and I was happy to listen to Babette before. We are a small company yet. We are 30 people. We have been incorporated in 2012, and we are based in France. And we will produce very soon. We will start the construction of our first plant, which will be able to produce our acid in 2022. Because we were talking about the idea, convert the biomass into bio-based molecule, reduce the carbon footprint, having a better CO2 emission on a very low impact on the environment. But what next? We need to get to the scale and commercialize our products. So this is how we have settled our first plant. The construction, we will announce the beginning of the construction in a couple of weeks. And production will start in 2022. We will produce 16,000 tons of the acids, of the whole family of acids. And we have been supported in the funding. I can explain later on the second part of the morning session how it can be difficult for a small startup to finance this kind of project. But we have been helped by European, the EIB, but also the BBI that I would like to thank, where we have been able to get a grant of 20 million euros recently with a very strong group of companies to help us to support and to help us to move forward to the industrial scale. And the objective after that, after this first plant, is to duplicate and go somewhere else in the world to propose to our clients those bio-based molecules. And looking for new partners, maybe to go a little bit deeper and develop some derivatives with them. As we said before, collaboration is a key as well part for the success. So thank you very much, and I'm very happy to answer to the questions.
Thank you very much, Nicolas, and my apologies for the problems with pulling up your slides earlier.
No worries.
You managed that perfectly. You clearly showed Afferent's circular economy approach, aiming for circular processes from the very beginning. And it must be very exciting times to be building the first production plant. So congratulations on securing financing for that. And I'm sure we'll hear more about the company in the future as well.
Thank you,
Our next speaker comes again from a long-established company, Braskem. It's Mateo Schreiner Garces Lopez. He's Global Manager, Innovation and Business Development in Renewable Technologies. He comes to us all the way from Brazil, and for him, it's very early in the morning. So thank you very much for having fallen out of bed to be here with us. And there you are. I can see you. Can we hear you as well?
So thank you very much, Tatiana. It's a pleasure to be here. It was great sessions in the morning. So I'm here to talk a little bit about Braskem, right? So just a quick introduction. So Braskem, it's a large petrochemical company, right? Basically today, Braskem is the largest polymers producers in Americas, including Brazil, Mexico, US, right? We have spread industrial capabilities in Brazil, Mexico, US, in Europe, and a commercial operation in Asia. But I would say that the most important thing that I would like to comment about Braskem in this introduction is a commitment that we did about 1 week ago, I think it was last Wednesday, that we announced our commitments in terms of sustainability, right? I think we have been working for the last year in this vision, right? And basically here we had a big ambition in terms of plastic recycling, right? As our fellow at Mitsubishi mentioned, right? It's an important part of this transition, but also a strong commitment in terms of carbon neutral, right? And so basically today, right, we have great challenges ahead of us, right? As we are a large, industrial group, right? Basically, we need to somehow neutralize 11 million tons of CO2 that we emit every year, right? Which is already a huge challenge for us. But we also want to support our clients, our partners in this transition as well, right? So it's not only about neutralizing Braskem emission, but also supporting, creation of a new sustainable value chain to our businesses and to our future businesses as well. But of course, that journey, it didn't started past week, right? Past Wednesday, right? It started, I would say, 10 years ago, right? This year, I mean, we are very excited that our green PE is completing 10 years old, right? It's becoming a grown-up. So 10 years ago, we started up our green PE facility, right? You all probably heard about the green PE. And from there, we also have been expanding our portfolio to other products, right? So we expanded to ETBE, right? It's a chemical based on ethanol. We expanded recently in partnership with Allbirds to green EVA, right? For shoe soles and so on. And as I'm going to lay out on the next slides, we also have been working in a portfolio of other products, right? So we are working in partnership with Haldor Topsoe to produce the BioMEG, the bioethylene glycol, right? To enter the PET value chain as well. And we also have been working internally on the green PP, right? We also have a portfolio of products that are not public yet, but somehow Braskem's strategy is very focused on delivering those renewable commodity polymers, right? And it was very nice to hear Luis' presentation in the beginning, right? Talking about the three main things that you need to find, or you need to reach to be able to access larger markets, demonstrate sustainable benefits, price, and performance, right? So basically, in my presentation today, I will focus on one specific topic, right, which is the LCA, and we'll talk a little bit on performance as well. But just to share here some introduction that somehow, I mean, as we are focused on those commodity chemicals, right, we also have a challenge on get to the cost structure, right? But somehow we believe that a value proposition that we focus on environmental performance, right, and I will explain how we are doing that, is also enable us to get the premiums that we require in those initial plants where those technologies are still not on full scale, right? somehow Braskem managed to commercialize those products with premiums and find those niche markets, and which has been our focus on those last 10 years. Really try to find where are those niche markets on those huge commodity markets where our clients, they valorize those sustainable attributes. So basically here's some introduction about the polymer markets, right? I don't know if everybody's aware here, but it's a huge market, right? As you can see here on the slide deck. Braskem is focused on the commodity chemicals, right? So we are talking about PE, PP, PET, even PVC, right? So Braskem is a larger producer of PVC, and basically the way that we are seeing our future, right, is basically trying to produce the renewable form or the renewable substitute of those polymers here, and not only producing those polymers, but also try to expand the utilization of those polymers to somehow try to use those polymers as a carbon capture tool, right? So basically, when we did our analysis and we saw this future, and somehow we are going to overshoot the global emissions, which means that we are going to surpass the 1.5 or 2 degrees limit that the IPCC puts as a challenge to the society, right? We will need to take CO2 from the atmosphere. And when we see the potential technologies that enable us to do that, they're still expensive and they're still far away, right? But we have a possibility here, right? A technological possibility here that we see as a great opportunity to actually use plants, sugars, and biopolymers to reduce the CO2 emissions, right? So basically, our strategy on the next years is to learn how do we maximize this CO2 absorption or the CO2 capture to really tackle this challenge and use the bioplastic opportunity as a tool to capture CO2. We also have been working closely with companies and governments on mandates, and also companies that also share our vision. And that also has been allow us to explore this market effectively. And we also believe that, by investing in renewable polymers, right, or renewable chemicals, somehow we also are disrupting our industry, right? In the back of this figure, right, you see the petrochemical value chain, right? It starts on oil extraction, producing of the basic chemicals, the ethylene, the propylene, and also going to the ethylene oxide or the ethylene glycol and so on, right? So those, this petrochemical value chain is very complex. Several players, billions or hundreds of millions of dollars invested. And basically what we are looking for is technology that are more simple, more scalable, and also with high yields and high efficiency to go from a sugar or a biomass or ethanol or a widely available renewable raw material to a final product, right? In that sense, we can reduce the investment to industrial unit and be able to produce those chemicals locally, right, from renewable sources, and somehow leverage as much as possible the sustainability in logistics, raw material sourcing, and so on and so forth, right? We also have been more and more connected with the downstream value chain, right? We have our renewable sourcing strategy, right, policy, that basically, it's kind of pushing the limits in terms of a sustainability of our raw materials. So we have been working closely with our partners, with the ethanol production, with the sugar production, to work together with them, with our partners, to increase the LCA or improve the LCA of raw materials, right? And that's has been the focus of our green PE and the green ethylene and the ethanol products that we have today on the portfolio, right? To focus on, you know, the CO2 capture, how do we manage the agriculture properly, and also how do we improve our industrial process to also reduce our CO2 footprint, and of course try to deliver along the value chain the most sustainable products that we have on the market, right? To our knowledge, right, our products today, that they have the best environmental performance within the market. And in this graphic here, right, we kind of show those numbers, right, where we started with the green PE and where we are right now. So basically, year after year, we have been looking into possibilities to improve our LCA, especially our CO2 footprint. Right, today, for example, we are working with our partners here in Brazil to talk about capture of CO2 and ethanol plants, biomethane production from vinasse and ethanol byproducts in Brazil. We're also looking into expansion in the US and looking for sustainable raw materials. So I would say that in a few words, right, our strategy has been to really try to manage the value chain from the production of the crop until the delivery of the product and the end of life of the product in a very structured way, in a way that we can track and we can show very clearly where are the emissions and how do we push those reductions forward. And so that's the potential numbers that we have on the green PE, right? So I just mentioned this number of the 309 capture of CO2 using green PE. So that's the number of the petrochemical PE. So basically, when you're substituting petrochemical PE for renewable PE, you get an abate of almost 5 kilos of CO2, right? Which is it's a huge number, especially for our clients that are also committed with carbon neutral. We expect to get those numbers on green PP, on green ethylene glycol as well, right? So basically, by enable those polymers on the market and the wide adoption of those polymers in the future, that we truly believe that will happen on the next decade, we could enable greater impacts, right? So that's kind of a rough calculation on how those markets could have, or how those renewable polymers could affect total emissions, right? So when we think about 10%, if 50% or even 100% of the market, right? So you get to those millions of tons of potential reduction of CO2 by using those polymers, right? I mean, we could imagine, you know, getting to 1 billion tons of CO2, you know, by also leveraging other polymers, other materials, and so on, right? So a final message here in my presentation that Braskem is very committed, right? As I mentioned, right? Not only to neutralize our internal reduction, but also to support our clients in this journey. Right, our strategy is very focused on renewable sourcings and get to, you know, the depth of how we could have a more sustainable agriculture and make sure that we will feed the planet, we produce raw materials, and we will conserve our resources as well. But we also are very keen into new partnerships, new potential partnerships to accelerate this journey as well. So thank you very much. I'm also open to answer any potential question.
Thank you very much, Mateus. It's nice to see a large brand taking on the challenge of changing the petrochemical value chain, and how you sort of position it to have a different business development to include sustainability and LCAs in the products that you bring to the market, into the intermediates. So thank you very much for that.
Thank you.
With this, we will skip back to Europe, to the Netherlands to be precise. And the next speaker up is Ed de Jong. He is VP Development at Advancium. I can see his slides.
Okay, I should also come on the screen, yes.
That usually takes a little moment, and oh, this is exciting. There you are. Excellent. Go ahead, Ed.
Okay, good morning, everybody. I'm apologizing already for the many slides I have, so some of the slides I will go through rather quickly, but I think you can see them afterwards. Let me see how I go to the next one. Good. I think everybody has already seen that plastic becomes an issue, and at the same time, the consumers really want to see a shift to circularity and to decouple plastic from fossil feedstock. So, I mean, I don't have to explain the problem to you. I mean, we have a global warming issue, but certainly also we have a circularity issue. Yes, I mean, fossil feedstocks are finite, and I mean, it can take 50 years, it can take 100 years, but on the longer term, we really have to come to a circular solution. And today, I like to present the direction Advancium has taken to go that way. So, if you look at plastic, I mean, you can see it has become an enormous success. In some aspects, certainly if you look at in volumes, and the predictions are actually that it will even quadruple in the upcoming 30 years to more than 1.2 million tons, a billion tons. So that gives a couple of issues. I mean, and we will discuss them in more detail. So, first of all, we have the volume. We also see that the share of plastic from oil will rise substantially. So also therefore the plastic budget in the plastic share in the carbon budget will rise tremendously from 1 to 15%. And also if you are not improving our collection and et cetera, the share of plastics in the ocean will rise quite significantly, both on the microplastic level as well as the macroplastics. And of course, macroplastics, I mean, is something that you can change with behavioral attitude, but microplastics is really something what is inevitable correlated with the use of plastic, for example, because of abrasion, like tires or clothing. If you look on the left side of the picture, what are the major uses of plastic? I mean, then packaging is by far the biggest, but also the other markets are quite large. So we have to go to those kind of plastics which can be recycled, which are truly circular, but also have a minimal impact on the environment. Oh, I don't see my presentation anymore. Good, I'm back again. So what are our solutions? Advancium has a vision that we create disruptive technologies and bring them to the world as partners to accelerate the transition towards renewable and circular products. I think the word partner has already been mentioned by many of the other speakers, and I think it certainly shows when you really want to make something disruptive, you need partners in the value chain to bring them to the market, because else it will be a very difficult task. In the spring, we were mentioned by The Guardian that we had developed a plastic what could be great in 1 year, and that created quite a bit of buzz around that. So you see here some of the newspapers. Because basically, I mean, you have a fundamental issue. Yes, on the one hand, you want to have, for many applications in plastic, what is very durable, what has, for example, very good barrier properties, what has good strengths. And at the same time, you want a plastic what is not persisting in nature. And that combination is very difficult to achieve. And I think we think that plastic based on FDCA, what I will discuss later, are some of the plastic could fit this niche area, which have very good properties, and at the same time are reasonably well biodegradable. So, what is our proposition? And that is basically making a polymer what is very similar to PET, but contains a different building block. It contains a furan dicarboxylic acid as a building block, and not terephthalic acid, what is coming from fossil feedstocks. Together with MID, what was already mentioned also by my predecessor from Braskem, what can be made from fossil feedstock, but also from bio-based feedstock. Potentially, you can make a completely bio-based bottle, or bio-based polymer, which you can use, for example, for bottles, but also for films and fibers, and what is fully recyclable again to the starting material. I said so. Hey, you can, with PEF, you can make a complete bio-based bottle, while with PET, that is in potential also possible by making a bio-based terephthalic acid, but that is much more difficult, and also from a cost point of view, it's more difficult. So, why is this molecule now so interesting? I already mentioned the barrier. It also has a very high glass transition temperature, so you can pasteurize in the bottle, and it has good strength. The next slide really gives a summary of the difference between PET and PEF, and I only want to mention here especially the barrier properties against oxygen and carbon dioxide, and that really makes it possible to do lightweighting, or to replace, instead of in a multi-layer bottle, replace polyamide films, or with PEF, and by doing so making it completely recyclable. So that are really technological improvements what really gives value to the material. So what are our key developments? Currently we are busy with the flagship construction. We are more or less, as we speak, finalizing our feed phase, the front-end and engineering design, and next year we will be groundbreaking to the first plant. You can see already the size that it is a relatively small plant, 5 kilotons, and in that respect much smaller than the commercial PET plants, and then therefore initially not cost competitive on a resin base. So you really have to look really in the cost competitiveness in the application area, because you can do lightweighting, because you can make it completely recyclable, and those kind of things really make it an interesting cost perspective. Here you see our scale-up strategy. So the first plant we will build ourselves, and subsequently we will go to licensing model. You can also see a kind of cost structure development, and you can see that only on the very big scale you will come close to the PET price, depending a bit also on the oil price, as well as the CO2 price, which are existing. Circular economy, a couple of words on that. Preferentially you will go for reuse, but we have also shown that you can do both mechanical and chemical recycling of the PEF, so it makes it a very circular molecule. And also what is very good to know is that basically all the processing equipment that is used for PET can also be used for PEF, and so there is no adaptation necessary by buying new equipment for processing of PEF. So you get a fully circular solution for PEF. And what I mentioned already before a bit about the biodegradability. So this is some work we did together with a Belgian company, OWS, and we looked at the biodegradability of weathered and unweathered PEF and PET, and the two bottom lines are PET, and these are the purple line is weathered and the green one is unweathered PEF. So you can see that it goes very nicely to very high conversion rates. Only if you look at the total timelines, I mean, it doesn't really fulfill the industrial composting requirements, so it is much slower biodegradable than PLA, but you can see it is much faster biodegradable than PET. So in that respect, I think we think that it fills in a very nice void between really biodegradable but not very durable plastics and durable plastics which still don't persist in nature. So the conclusions, and to finalize my talk, is that yeah, the circular economy is really the solution for many of the problems we are now facing, and that PEF can really be an instrumental part of that because it has very good performance, it is fully recyclable, it's bio-based, and it doesn't accumulate in nature. And with that, I'd like to thank the audience for their attention. And if you have any questions, you can reach me directly with this email address or by this telephone number. Thank you very much.
Thank you very much, Ed. And indeed, all the slides and recording will be made available by the GBS organizers later on, so people can also look through the slides you had to speedily go over as well. You took up two of the aspects mentioned by Sarah in the beginning, the partnerships to achieve results and also the ambition to revolutionize the plastics industry, you wrote on one slide. And of course, producing biopolymers with novel properties really allows for a smart design in circularity and in advantageous properties for them. So I think that's a very interesting way to go forward. Thank you very much. So smart design, I think, is also a good segue into our last speaker's presentation. This is Jason E. Camp from the Circa Group. He's Chief Technology Officer. And I have to admit, I don't know where to place him geography-wise, because Circa to me rings Australia, UK, and I think now France. So Jason, please go ahead with your presentation.
Thank you very much. I'm joining you from sunny Didcot, which is right outside of Oxford in the UK at the minute. So thank you very much for allowing me to speak today. I want to tell you about Circa Group and how we're delivering on the promise of bio-based molecules on scale. Hopefully this works. Perfect. So Circa Group was founded back in 2006 with the bioeconomy ambition to exploit natural attributes of the world's most abundant polymer, that being cellulose. What we've done is we've developed a unique large-scale process for the production of a platform molecule that we call levoglucosanone. It's a patented process, and that's from non-food waste cellulose. Now LGO, I think we have a cursor here, can be converted via well-established chemistry into a variety of derivatives, and these derivatives have been found to be useful in an even larger variety of applications. And just to talk about scale, I think that's something that's been very important and touched on a lot today. Really, we've managed that scale up by hitting certain milestones. We've been able to move fairly quickly, I would say, on the grand scheme of things, from that benchtop scale to where we are now, which is a pilot scale plant in Tasmania that produces about 20 tons of our core product styrene. And we've just been awarded some funding, and we've just started the program to build a 1,000-ton plant in France. And what we've been able to do is develop an environmentally sustainable, commercially scalable product that's much, much cheaper than any competitors that are out there. And really what we're focusing on is this as a building block to lots of different products. And that's really what's key for us, is being able to understand both the chemistry at a fundamental level, as well as the very far end, who's going to buy this, what sort of products are these molecules going to go into. There we go. So just a little bit more detail on the Horizon 2020 project. So we were awarded a big flagship grant back in 2019, and that's to build a 1,000-ton styrene plant, and the co-product with that is 5,000 tons of biochar. And that's what really gives us the great sustainability credentials as well, is we're utilizing a lot of that mass that's coming through the process. We're working with 11 expert partners, including IAR, and they cover the complete value chain. We started back in October of this year, and we're looking to commission that plant in Q3 of 2022. And really what this has allowed us to do is take styrene, it's a solvent, I'll talk to you about that in more detail. And as we increase the production capacity of this platform, this big solvent type market, we're also further able to develop higher margin LGO derivative markets. So really having this dual stream of business allows us to be very flexible and has allowed us to get to that economy of scale very quickly. So just some more details about styrene, and really the focus here for us as a company, I think it's very important to put this at the forefront, is that we're regulatory driven, not subsidy reliant. And where that comes into play is we're seeing this once in a generation upheaval of the chemical market, and really this push to push out toxic chemicals, and that's being driven both by regulation as well as industry itself. So styrene is a dipolar aprotic solvent. It's safe, it's sustainable. We've sent out over 1,000 trials to customers around the world, and the feedback that we're getting is that it outperforms traditional solvents in this area, such as NMP and DMF. These are very high concern within REACH in 20 to 30% of applications. And it's widely acknowledged as one of the very few viable replacements in this core area of solvents. So we like to say at Circuit that REACH is our friend, and really a driving force for getting people to look at this as a product, to bring this into development within their processes. So just one very quick example here where styrene is outperforming existing technologies, and that's where we've worked quite extensively with commercial focused third-party researchers, be it in academia, be it in industry. So James Clark, among others, have found that taking styrene and dispersing it, taking graphene, I should say, and dispersing it in styrene allowed for a significant increase in the concentration. And what that really means is that you get the lead time increases, this cost of production goes down, and that's versus this industrial toxic solvent, the industrial standard NMP. And where this has been useful is in the production of graphene inks, both screen and ink printing. So not only can you take graphite and convert it to graphene in a much more sustainable way, but then the next iteration, what do you do with the graphene, is also facilitated by using styrene. Furthermore, graphene is being used in lithium-ion battery technology. It's being used in water purification membranes, and all of that research is being done using graphene and styrene solutions. So I mentioned briefly at the beginning that we see LGO as a platform molecule. We also, it can be qualified as a bioprivileged molecule under this definition of Shanks. And that's where we can take this diversity of chemical products can be made, both novel molecules and drop-in replacements from this biological derivative. So this is normally the point in the slide deck where I need to apologize. I'm a recovering academic with a background in synthetic organic chemistry. And what a slide like this means to an organic chemist like me is we have this chiral 3D molecule, LGO. It's got lots of functional groups on there, and the reactivity of those functional groups is very well understood. So what that means is it gives lots of confidence to people that we're selling LGO to and other derivatives, that they'll be able to convert that into the molecules of interest to them. We've put together about a 250 slide PowerPoint presentation that covers that reactivity. So LGO to make X, and people can look at that and say, well, I want to make that compound, and here's exactly how to do it. And so just to give you an idea of what I'm talking about here, apologies, I hit the wrong button. There we go. Sorry. So to give you an idea of what I'm talking about here, we see LGO and its derivatives in a variety of different markets. Solvents are one of our key markets at the minute with styrene. Pharmaceuticals, so you can see here the cores of molecules like remdesivir, duranavir, which is a 2 billion pound a year antiviral, can be made directly from that LGO platform. flavor and fragrance industry as well. So we've developed some synthetic methodology to get into a compound called dairy lactone. That's very interesting in the powdered milks as well as flavorings for non-milk-based products such as yogurts and ice creams. In the agrochemical market, LGO can be converted into existing agrochemicals, such as this one shown here, where the functionality can be converted into these two parallel centers. We've done some research internally on the formation of a pheromone called Japonolure, and also have some really good detailed background on a novel herbicide called PT139. And finally, we're seeing applications in high-performance polymers. We've talked a lot about polymers today, and there's a lot of different ways that you can add basically the carbon from waste wood chips directly into bio-based polymers. You can use it as cross-linkers, as in a molecule shown here, or you can make bio-based polymers directly from that scaffold of LGO. So, bit of a whirlwind there, trying to get us a little bit back on time as far as the timing for this conference goes. But I just wanted to give you an overview of Circa Group, of Cyrene, of LGO, where we're going and how we're planning on getting there. So thank you very much for your time, and I look forward to answering any questions that are coming up. Thank you.
Thank you very much, Jason, for that overview, dipping into chemistry and also coming back out again. What I took away from it is really that an analysis of the intermediates and their potential is very important, that you chose one key market which is in creating a new solvent, which is not only sustainable, but also has improved performance and characteristics. And from the example you gave with Cyrene, this is really relevant for many technology areas which are far away from bio-based industries, but will have a huge impact in really many areas there. So thank you very much again for a presentation.
Thank you.
And with that, I would like to close this session of all the different presentations we have. Thank you. There's already the workshop agenda back. We got quite some nice explanations and glimpses and visions of how bio-based processes and products can go to scale. We've also heard recurring issues around this, such as sustainability, sourcing the carbon, biogenic gases, recycling, non-food, all the challenges of scale in having small scale, large cost, small volume, but high cost, and in the end, the pricing and performance. I'm really tempted to go into many questions now, but I shouldn't, because we have the breakout sessions where also the audience will be able to ask questions. I have to admit, what we've decided in the background now was to skip the Q&A session, because I've seen that our speakers were already so kind as to answer all or most of the questions in the chat already. Thank you very much for that. It's been very active and interactive there. So we would skip this Q&A with the speakers and go directly to the parallel breakout sessions. We have one on market development and regulation and one on financing and investment. They will be in Zoom rooms. So those of you who were here yesterday, today is completely different.
I think we are pretty filled up with more than 30 participants. So I will start from here. Thank you, everybody. I'm Marcel van Berkel. I'm working at the Circular Bio-based Delta as Business Development Executive. I do that part-time, and for the other part, I am independent consultant supporting different startup companies and other companies who have interest in business development, strategic planning, financial planning, and investor relations. Looking to the panel, we have 5 members. We plan to have 6 members, but our Braskem member, Matthias Lopez, he said he needed to leave. Well, for him, it's still midnight, so probably he is hitting the sack again. So at our panel, we have Babette Patterson at De Jong, who we already know, Jason Kemp, who we have seen in the presentations. And apart from that, Sarah Hickinbottom and Takehito Bendo. Those are actually new, so I will ask them later to introduce themselves. But I first want to make a round. I think introduction is not really necessary anymore, but I like to start with the first question to the panel. And that question is, how does success look like in market development, and what are critical success factors? We have seen in the presentations that 3 of the presentations, they received a BBI flagship subsidy grant. So that can be an important reason for success. Tatjana, you wanted to ask something?
No, I did not. I just requested all participants to please mute themselves so that we can hear the panelists talking. Sorry.
Yeah, very good, very good, very good. So then I'd like to go to the first. I'd like to start with Sarah, because she can do also a short introduction. And please give me your feedback on the question: how does success look like, and what are typical key success factors?
Thank you, Marcel. Well, I spoke at the very start of this workshop, but I didn't talk about myself. Yeah, I'm the CEO of BioVale. We are the cluster partner, obviously, in 3BI, representing Yorkshire and the Humber, the north of the England in the UK. I have a background in bio-based business and consulting, which includes actually an awful lot around the world and agricultural feedstocks. I spent 15 years in that world and worked with actually an awful lot of the companies that have been speaking today. And then I'm absolutely thrilled to take on a new challenge to build the bio-based economy more directly than as a consultant. In terms of what success looks like, obviously there are a myriad of answers, but not to steal people's thunder. I think the sweet spot that was mentioned from Dupont was extremely good. It's that idea that we have to compete on price. In fact, I would add on the need to compete on price, the need to compete at scale according to the market that you're targeting. So just-in-time delivery, et cetera, et cetera. It may be that you have to actually change the market you're targeting, i.e. target a higher added value market with lower volumes, or change the downstream expectations in terms of volume and price, et cetera. Performance plays a huge role in that. Go back to first principles, improve on the status quo. Don't assume that like and like is what we want. And thirdly, and obviously, all of us are here partly driven, or in a lot of our cases, completely driven by the want to future-proof supply chains and tackle world global sustainability problems. So that's what I'll say success looks like.
Thank you so much, Sarah. Thank you so much. Then I will switch to Takehiko Bando from Mitsubishi. I don't think we have seen him today.
Yes.
In the presentation. Hello. Good afternoon.
Can you hear me?
We can. Very good.
Great. My name is Taki Bando, and I am the senior manager at Mitsubishi Chemical Circular Economy Department, and I work under Kanazawa-san, who just made a presentation briefly before. I'm currently now in charge of circular economy related business development. And previously, before I have been the project manager of BioPBS. It's our bio-based biodegradable polymer. And actually, I was responsible for its commercialization. And I've been working on that for almost 10 years. During that experience, what I think I could consider successful, or at least if I would have achieved it, thought that was successful, is that if both value and volume from, for example, sales have met expectations, I think that is one sign of success. The reason why I think so is that I believe that whether it's new or existing biomaterial has to be accepted in the market, and who decides whether it was accepted by or not is the consumers, the customers. And I think the more sales at a certain price point that we at least justifies our business is definitely a sign of success of that business. Thank you.
Thank you so much. Thank you so much. Then I would like to move to the next panelist, which is Babette Patterson from Lanzatech.
Good morning. Thanks, Marcel. Did you want to, so I think those who weren't there in the previous session, I'm Vice President of Europe for Lanzatech, working to build our business here in Europe. And Marcel, did you want me to comment on the first question, or just to take any question?
The first question, please.
Okay.
How does success look like, and what are the critical success factors?
Okay, thank you. Well, obviously from our presentation, what you will have seen is, for us, success looks like commercial scale, and that means, significant operating hours, well beyond proof of concept, and sufficient funding and financial support to actually be able to provide a product at commercial scale to the market. Just to comment on, Sarah, what you said, and to go back to the Dupont presentation from Luis, while obviously these new solutions, bio-based, circular, or recycled carbon solutions, need to be competitive, I think what we're finding today is a very different situation than 10 years ago when I started out in bio-based chemicals, which is that there are customers who are actually willing to pay more. Now, obviously, there has to be a path to a competitive economic price point at some time, but we're seeing a very, very different situation in the marketplace now, where potentially, given the legislation in Europe, the Circular Action Plan, the Green Deal, and the targets that have been set, many of our customers need to move much faster to meet those targets in 2030, and therefore are willing to pay more for a period of time, and see that consumers see value in that, in our case, in a recycled carbon solution. So success, I think, in summary, really is commercial scale. Market demand is extremely important. There's no point in having commercial scale if there isn't a market out there. And obviously, one has to apply that at a competitive price point.
So that means that regulations are also helping quite a lot, what we are seeing today.
Yeah, regulations, obviously, for us are absolutely critical. One of the reasons it's taken so long in Europe versus in China has been the challenge of influencing regulations to align with the plans that we had. So yes, both policy is extremely important.
Yeah, we see that also in the regulations on the recycling. Then I like to give the floor to Ed. Ed, can you switch on your?
I will unmute. Should I?
Yeah, very good.
Good morning, everybody. I mean, at Advancium, commercializing bio-based building block FDCA for, among others, applications in the polyester PEF. Yeah, for us, I mean, success would really be an operational plant, what really is appreciated by brand owners, so that it also completely sold out. And yeah, we want to achieve that by the end of 2023. So yeah, we have exciting times ahead, and yeah, I think the combination of functionality. I mean, basically what also was told by Luis from Dupont. Yes, I mean you have to be in the sweet spot. And yeah, one remark maybe. I mean, you can see in our development trajectory that we initially the material is quite expensive because the plant is rather small. But we already have a lot of commercial interest from brand owners to do that, because basically it is not the polymer as such, but it is really the let's say packaging solution what really defines actually the price. And if you can really make it recyclable, going to lightweighting and those kind of things, actually a more expensive polymers such as PEF can still be very cost competitive and interesting for brand owners to apply. And so I think that is one of the things what is sometimes forgotten in this discussion about scale and market introduction, that initially you can really address other markets to get the thing going. And if you really have proven that you can produce the material at scale at quality, I mean, the subsequent road to scaling up is possible. But you need this kind of stepping stones. And I think that is one of the things, maybe a little bit more for the financing part also is, I mean, to finance those kind of stepping stones is a kind of challenge nowadays in the world. Maybe
okay.
Here.
Very good, very good. No, that was very clear. And then I will give the floor to Jason of the Circa Group. Jason, where are you? Can you switch on your video and unmute?
Yep, I'm here. Thank you very much.
Very good.
Yeah, I completely agree. I think with everyone else that's been speaking today. I mean, you know, just a couple of little points I wanted to pick up on, and I think that, you know, Ed had a great point there that, you know, if we're designing something from scratch, you know, it should be better than, you know, you don't want replacements. I think that that's something we're very much trying to do in the products that we develop, is give something that's going to be better than the existing technology. And what that better than, and it's sort of that issue of success and how do you get there. You know, the key sort of marketing information for us, especially around price, is that people need to look at the complete value chain. So they need to look at the cost of use rather than just the cost to buy. So for example, with our solvent Cyrene, the cost of use is significantly lower because you don't have to send it off for incineration. You're not contributing to greenhouse gases in the same way. You're not making NOx and all of these sort of things. So when you start having those conversations with customers and explain to them about the cost of use, what are the properties of this solvent, what are the properties of these derivatives that make it better than existing, you know, that's where we're able to sell on the product itself rather than just the fact that it's bio. The fact that it's bio is important for certain clients. That's the key driver. But I think having a diverse portfolio of compounds, of solvents, of intermediates that meet a lot of different sorts of client needs is very important. And that's something that we're trying to do more of at Circa Group, is diversify our offering to meet all of those clients' needs.
Okay, very good. Thank you so much. That is clear. Functionality and performance, additional functionality, especially in use, what is more important than the initial price. I like to do a Slido question, and Tatjana, can you help us how to do that exactly? Oh, look here, that is very helpful. So we first start with a very easy question, just to as an icebreaker, and just to see if it's all working. So what time is it for you at the moment? Morning, noon, afternoon, evening, or are you in your pajama or any other housing easy closing? I see 5 answers, 6. We have, how much participants do we have? Look, yeah, it's getting better, but we have about 90 participants, I thought. 48 participants. I see 11 answers. We need to, there's coming more. Okay, I think we leave it here for the icebreaker. I had hoped to see a little bit more, but I think it's already good. So let's go to the first serious question. What are the main challenges in bringing drop-in bio-based products to market? Oh, that was a difficult question. Nobody answered yet. There we are. That is very much reflecting what what some of the speakers said. Reaching commercial scale, getting sold out, but get to
Marcel, at Young speaking, I'm missing a little bit the cost position here. I mean,
yeah, but that is, you know, that is always, I think that is always a criterion.
Yeah, but certainly this drop-in is the most important one.
Yes, but that is much more a qualifier than a differentiator. And I think if you, even if the cost price does not match yet, get the green premium is also important next to cost price. Okay, thank you for those who have answered this. Then I would like to go to the to another question about typical timeframes. What are typical timeframes to bring in drop-in products or novel products to the market? Is there a difference between both, and how could they be shortened? Something what we see at startup companies is that they are very much focused on technology and usually less focused on market development and market introduction. And that's why I like to ask this question to the panel and how they think or how they look at it. So please, let's start at Babette Patterson at the moment.
Sorry, Marcel, I was asking, yeah, I was answering a question on chat, so could you just very quickly, trying to multitask it, could you just very quickly repeat the question? I'm sorry.
Oh, I'm sorry, we were
main
looking
challenge.
Typical timeframes. Typical timeframes
okay.
To bring drop-in or novel products into the market. Is there a difference? And how could those timeframes be shortened?
Right, so I think there's a sort of well-known study by McKinsey which always stated that it takes at least 10 years to bring a new polymer to market. And they do have that grid, which you're probably all familiar with, which is new product, new market. And obviously, as you move to both of those things, the timeline gets longer. If I look at what's happened at LanzaTech and previous early stage companies where I've worked, I mean, 10 years is a minimum. For sure, if I look at LanzaJet, which we launched this year, that is basically 10 years from the time the company was started. So I think it's more different if you're a small company and have different financial means versus a large company that's established. And for the small companies, you did talk about, is there a difference between drop-in and new products? There may well be, because effectively what we're doing at LanzaTech is producing polymers, polyethylene, polypropylene, polyester based on recycled carbon. So they're identical to the fossil-based products. They're just based on recycled carbon instead of fossil fuels. Had those been different, I think you have a little bit of an added time if you're dealing with novel products, because you then have to get those accepted by the marketplace and by the consumer. But to actually get from a small company through to commercial success is probably 15 to 20 years in terms of revenue streams from the time you found the company and have the idea. I'm looking at Ed, who may have a similar timeline or different, which means you have to be very clever at raising money on an ongoing basis, which you can do so long as you meet your milestones. I think that's really one of the keys to success for us.
Mm-hmm.
We'll continue to get support longer term, so long as you can meet the milestones that have been set out.
Absolutely, absolutely. It's very recognizable. At DSM, we brought Dyneema to the market. Took at least 10 to 15 years. And also think of PLA, what NatureWorks did. Of course, yes, a startup company, but also a joint venture of large companies, and had different partners during that time. So not easy at all. Then I'd like to go to the next panelist. Ed, can you give us some comments and your view?
Yeah, no, I think the 15 to 20 years for a new molecule is probably accurate. I think we see the same, and certainly, for example, a new polymer is even more complicated. Certainly, if you want to bring it, for example, for food packaging, because then you have to go to some additional regulatory hoops. So. Yeah, I mean, unfortunately, it really takes something like 15 to 20 years to go all the way from the first ideas to actually commercializing. And just an example from us, I mean, we started our pilot plant at actually the DSM facilities in 2011. So we have now already the pilot plant producing material what can be tested at partners in their facilities, already running for almost 10 years now. Yes, and you really need that to secure offtake, but also to really prove that your product has really those technical improvements which you got indications for in the lab.
Okay. Thank you so much, Ed. I get the message that our time is running out. Time is moving fast when having fun. But I still would like to give the other three panelists the opportunity for a short remark. Sarah, can you give us a remark on the question?
Thank you, Marcel. Well, not to repeat, obviously, what's being said, I'd add in reiterating regulations and also access to finance. So in terms of regulations, we all know that it's a huge challenge. When we talk risk, you can mitigate and work with technological risk. You can design everything you're doing from a market pull perspective right from word go, but increasingly regulations can stymie innovation. And also when I talk regulations, I'm including policy, and that includes the subsidies that the petrochemical industry enjoys. Increasingly, the world financial industry is seeing the need for change. And as we head into COP26, I was involved in an enormous event last week in London, well, remote, but from London, talking about the need to remove subsidies and also talking about the need for introducing a effective, operational, fully supported by governments and organizations across the board carbon trading market. I know that's something that we could talk about for the next hour, but it's really something that the next 12 months is going to see great change with.
I can imagine. Jason, can I give the floor to you?
Yeah, just a couple of points to pick up on there, and I think we've covered a lot of the areas. I think it's scale and regulation, and I think those go hand in hand. So for our big solvent styrene that we're going to be producing on 1,000 tons per year, we need to go and get REACH Annex 9 authorization to be able to build that plant, and that's not a little endeavor to do. But as far as timings to market, I think you have the opportunity for a very small niche market with a high volume. So if we wanted to spin out something to make pheromones derived from LGO as an example, that would be something that would be fairly quick to get into the marketplace because it's an established molecule. It's a very small niche area, but the payback can be quite high. So I think that it's trying to get that balance right of, if you want to be making things on very large scales, regulation can slow things down, but you might be able to sneak some things in that on a much smaller scale that have a higher profit margin. So, can you, our method is to use styrene as a Trojan horse to get our volumes up so that we can now look at derivatizing into lots of these smaller markets that have much higher profit ratios. Thank you.
That's typically also one of the sweet spots if you can find those type of markets, and helps you also with the over the value of that with small volumes typically. Very good, very good. Taki, can I give the floor to you for this question?
Sure. Let me make a brief comment. I totally agree with everybody before me. For our biodegradable polymer, it took us, we would say it's 10 years, but actually it's more near 20. But at the last moment of a commercialization, what was very difficult for us is that if it's a new polymer with a different characteristics than the existing ones, it will be a hurdle for customers to actually not only test it, but go into commercialization. They need to buy new molds, they need to make some investments, and under uncertain, let's say, future for that new polymer, it is quite difficult to convince people to make investments. And that is, I think, one hurdle that we faced during my experience. Thank you.
Very good. Absolutely, absolutely. If customers need to do additional investments to bring new polymers to market, they must see very high value propositions and additional benefits. Regarding the time, I don't think we have so much time anymore. I like to give the panel the opportunity to give a closing remark. So, Taki, can I start with you?
Sure. Thank you very much for the opportunity. I personally have a very strong, I want to push it. So I hope that we all work together and make the world better with bioproducts. Thank you again.
Thank you so much. Thank you so much. Jason, can I give the floor to you for a final remark?
Yeah, again, thank you for the opportunity. And I think that, we are very much focused on businesses and getting our businesses going and up and running and making money. I think we need to also just remember why we're doing this and the impact that we can have on every person on this planet. And so I think that's something that sometimes we can lose sight of on. So I think that's something that I'll leave you with. Thank you.
Thank you so much. Sarah.
Well, to reiterate what's been said in terms of we collaborate, we all, we're a disruptive industry, we're doing the right thing. We have a lot to offer the world, as Jason just said, touching everybody. Work together, 3BI, the 5 clusters that are here organizing this event with the IOC. Work with us, talk to us, join us.
Very good, Sarah, very good. Thank you so much, especially pointing to 3BI. Ed, can I give you a couple of seconds for a closing remark, because the other group is already back in the main room.
I think Ed has just left a message.
He already left. Okay, Babette, please, we like to hear you then.
No, I just wanted to build on what Sarah said earlier. Be bold. It will take time. It will be hard. Persistence and patience will pay off. And to Jason's point, it's worth it. Let's not forget what we're doing this for. It's about climate change. It's about saving the planet. And that, at the end of the day, is what we're working towards.
Sorry, do you mind if I interrupt Babette? I'm going to go one step further. It's not just about saving the planet. The planet will live. It's about saving our species.
Thank you, Sarah. Absolutely.
Then I'd like to thank everybody. Thanks for the panel. Fantastic contribution. The audience have already posted a lot of questions in the chat. I suggest we go back to the main room and you'll see me there. Thank you so much.
Thanks, Marcel.
Bye-bye.
Thank you, Marcel.
Or Christoph, would you like to start saying something?
Yes, so we'd like to thanks again to panelists, yes, to join our parallelization. And we have prepared a couple of questions with Fuji for the panelists, and this will be a basis for discussion. And of course, a message to the audience, to the attendees: don't hesitate to send questions by the chat function, and we'll do our best to answer the question by the panelists, of course, provided the time we have left.
I hope we can have a lively session as much as possible. And so we hope any of the panelists can say anything about how the financing and investment should be, and what, if we can sort of make a common statement out of this room, that would be really excellent. And so something I would like you to bear in mind is your vision for 2030 in an ideal bioeconomy world. And for the big companies, how can the massive effort to revamp existing companies towards bio-based to be financed? And for the startups and SMEs, how can new innovative companies finance their novel process to be able to access market at industrial scale? And next one is going to be which management decisions are crucial for successful shift, and what can the industry lure or pull the ESG investment. In my mind, ESG has been given a lot to solar or wind, but I think we are doing something very good to the environment in terms of the raw material or the technology application. But I don't think we are gaining much of the ESG investment money as much as we need to utilize. And so that actually leads to my next question of what do the industry disclose to whoever is going to be the investor, and what should the investor be looking for is something I would like all the panelists to think about and say something about. So here I have set the scene. So I hope anyone on the panel willing to talk about anything of the these 4 questions, very welcome to say something. So anybody want to go first?
All right. Can you hear me, Yoshi?
Yes, indeed, Luis.
Yeah, so maybe I can just get this started, and you know, but definitely looking forward to engaging the discussion here. You know, you had on your slide, how should companies go about financing this, both large companies and smaller. Actually, I'm going to speak about smaller companies.
That's wonderful. Yeah,
if that's all right.
Experience.
And yeah, exactly. And I think I really like to emphasize the aspect of partnering.
Okay.
You know, we do not want to repeat some of the mistakes of, say, 10 years ago, when we had the big biofuels range of investments, a lot of money put into very expensive projects, both at smaller companies and large companies. And some of them saw the light at the end of the day, others not, right? Companies have assets that they are willing to partner with smaller companies to get that innovation. The example that I showed today, the plant, the JV that we have with Tate & Lyle, right? That took many, many years to put together. But Genomatica, which is a startup still out of San Diego, recently used that capability to produce not PDO, but BDO, butane diol. And we were very happy that they did that. I mean, think about it. You have a plant which has been running now for many years with all kinds of efficiencies. And if you have any downtime at all, you want to fill that capacity with valuable products. And so Genomatica provided that opportunity. What they did is, I think it's a bit of a blueprint for a startup. You have 3 levels of capital investment. If you can do what, say, Genomatica did, which is a true drop-in, here's my microbe, we designed it, it's gonna run into a process which is very similar to what you already have. Mm-hmm. I'm gonna drop it in, you're doing PDO, here we can do BDO, the modifications are small. That's ideal because the capital already exists, right? And your job as a small company is to bring something that is more profitable to run in those tanks, right? So any plant manager is going to be, yes, I want to fill my tanks with something more profitable. If your new process, if you're a startup developing a process, if your new process now is not a drop-in, if it is a bolt-on, meaning you can go to a plant, you can go to maybe a mill, and in order for your process to be adopted, some level of capital investment has to happen, some equipment, some unit operation. That is possible, but it already becomes less desirable, right? You've got to bring some more steel. Mm. And so the most difficult then is a process that is completely new, and you got to build it all from scratch. And I'm not saying that's impossible. I'm just saying that's the hardest one to justify. It's a true capital project, right? And the products really have to command that type of investment. So I work with a lot of startup companies, right? We want to partner, and we offer them our scale. And sometimes it's a good fit, sometimes it's not a good fit. But the opportunity that I see today, if I were starting a company with a new process, I would go after, in places like the United States, the corn producers. The folks who are doing ethanol out of corn, or who are doing high fructose corn syrup, carbohydrate processing. These are products that are not very valuable. People don't want to eat sugar anymore. Ethanol, you've got other fuels. These places are, they're struggling. They are craving more valuable products. And they have a lot of steel on the ground. They are very familiar with biotechnology. They've been doing all types of fermentations. There's a lot of cheap sugar available. Those places are great to come with a new microbe or a new process that can be almost drop-in or bolt-on. There's a very, very high chance you're going to find cheap sugar, and you're going to be able to provide something more valuable than what they're already making, so you can take advantage of that entire infrastructure. I think in other parts of the world, in Brazil, you would find a similar scenario around sugarcane, right? It's also under a similar economic stress. I'm less sure about Europe, if some of the beet sugar producers or others, if they're like a good point of entry. But I just wanted to throw a couple of thoughts out there on some of the opportunities that I see, for a company developing a new process and how to go about it.
Hey, thank you, Luis.
Thank you, Luis. Maybe I can add something as I'm running a small company, and we've been in the middle of all that reflection. And I think, Luis, thank you for the idea on sharing your point. I think one of the biggest challenges when you are a small company is how you can deal, apart from the financing, of course, but sometimes it's linked, but how can you deal with a big company? How can you protect your process? How can you manage with the IP? And I have to say that even if on the paper it's pretty interesting to work conjointly or with a big company, practically it may be sometimes a big risk or provide a lot of difficulty for small companies. So Sometimes either because the small companies are not playing the game because they are scared about their IP and they don't want to share a lot of things. Maybe because of the big company, which is trying maybe sometimes to put the end on the process, on the technology. I mean, it's not a question of who is responsible for sometimes problems, but the reality is when you are very small at the beginning, it's difficult. It's pretty difficult. You have one project for your company for a bigger one. It's one amongst the other. When I'm sharing my experience, it's always good to speak with people already in the market and can help provide raw material or even processes or facilities. And this is at the beginning the choice we wanted to push. At the end, I think it becomes much more easier when you have been able to get a certain size and you have been able to prove that your process may work. So I think the balance between both is a little bit better, I would say, to start something pretty useful.
Yeah, that's an interesting reflection there. You brought so many points of working, and maybe if I can just react to some, and I'm gonna let everybody else chime in too. But intellectual property, I think you brought that one. I think it's important to file your patents and file your intellectual property. But at the end of the day, big companies, I don't think they want to go and you know, learn the thoughts and go replicate it. You know, biochemical companies like Dupont, you know, I think a good analogy is the biopharmaceutical industry. So, you know, what you see in that ecosystem, you see all of the pharmaceutical companies. What do? The Roches of the world, the Sanofis, the Pfizers.
Und Treuti vom GBS, kann ich Ihnen vielleicht weiterhelfen?
Oh, just got something on my
Never
microphone.
Mind. Go ahead.
Yeah. Yeah. What you see with the big.
Wo sind Sie jetzt gerade unterwegs? Wo wollen Sie gerade rein? In den Workshop oder in die Breakouts?
Yes, you're on the workshop, so maybe you could mute yourself.
Ja, genau.
Thank you.
Okay, na wahrscheinlich, also wenn Sie sind sozusagen in der Plattform.
No, you're not muted.
Sie müssten erstmal also sozusagen sich in die Plattform einloggen, da sind Sie wahrscheinlich drin, das hat erstmal geklappt. Ja.
Well, let's carry on.
Okay. Yes.
We'll carry on.
Noch mal refreshen. Also
yeah.
normalerweise
We'll carry on.
sind Sie die
There's a little
Eingabemaske, wo
background
Sie
there.
Login und ein Passwort eingeben?
I think the point that I was making is a good analogy is with the pharmaceutical companies. The big pharmaceutical companies, they do a lot of their own research. They have the capability to put a lot of the new products out there. And at the same time,
da wir alle drin sind, sonst können Sie noch mal refreshen.
Yeah, you guys still picking that? Sorry, I got a little bit of a.
Waren Sie denn schon mal eingeloggt? Weil manchmal ist es auch so, dass sich so auf. Okay. Nee, das ist Herr Fröse vom BMF.
Das ist alles zu hören.
I'm trying to send a message.
Yeah. Do we have any questions coming in?
Yeah, okay. Maybe yes.
Go ahead.
I have a question, or it's a reflection that I was given 10 years ago when I was coordinating the European project for the biorefinery vision for 2030 for Europe. So I interviewed a lot of stakeholders, and I do remember one of the stakeholders told me, and it was a thoroughly experienced person who was the advisor of the French Prime Minister for biotechnology. And according to him, the main hurdle of breakthrough technology development and the financing of this development was the lack of stability of capital of companies. And if there is a lack of stability of capitals, it's lack of stability of strategy. And biotech and biorefinery technology needs time because it's a capital-intensive technology. And according to him, that explains mainly the success of Dupont, that have the assets, that have time to think long-term and invest into breakthrough technology. Does Dupont agree, and Mitsubishi Chemicals? Maybe. First, Dupont.
Maybe if I could jump in.
Yeah.
Please, yes.
So maybe before talking about this long-term vision, about back to the IP issue, I think it's to do with the sustainability, so to speak. If you have the reputation of IP theft, I think you won't be able to work with startups anymore, even large corporations. So large corporations themselves won't be able to do everything on their own. So today, large corporations will have to keep working with startups. And if there's an incident like an IP theft, probably no other startups will want to work with large corporations forever. So I think it's mutual that both sides will want to guard both sides' IP. So the agreement will need to be carefully written. So I think that's the starting point. And the long-term vision, when we pursued bio-PBS and bio that I talked about, bio-based plastics, I think that was greatly supported by the I could say strategy that the Mitsubishi set up around the same time that we are going to focus on sustainability. It's to do with the internal financing, so to speak. We have a number of competing projects, and the internally the bio-based plastics projects have to compete against other internal projects, and so if the top management has a belief in the long-term, bio-based products, sustainable products are going to be more and more demanded, then that becomes a big support for project managers as well as researchers who are running these researches. It's going to be very helpful to them. And externally, so that's more to do with the internal financing, but the externally, we're talking about long-term projects which there is a cash outflow at the beginning in terms of capital investment, and the cost is generally higher at the early stage. So we would like to see support from the government or some financing bodies for something like a lower rate for bio-based or environmentally friendly projects. I think those are very helpful. Thank you.
Thank you very much. Luis, would you like to say something?
Yeah, just unmuting here. So very much agree with Daisuke, your point on intellectual property. Reputation is everything. And if a big company takes advantage of a small one, they'll probably be the last time they'll do business with any small company and any large company. So I think our environment's becoming very much, I was saying, like the pharmaceutical companies. They obviously have a very good ability to do their own research and develop their own products. At the same time, they're very good at licensing innovation from very small biopharma, biotherapeutic companies to feed the pipeline, just because you need a variety of products and they have all kinds of expertise. We're becoming like that too. We develop our own products and we bring products from the outside. We have the capability, the scale, the marketing. So it's you have to learn how to do it ethically and properly. I think to your question there, Christoph, and on the, I think you're talking stability of financing, right, and the long-term vision. We invested a lot of money in cellulosic ethanol. I was actually running that program for Dupont. It was our largest program at the time, most expensive. We did not succeed. We developed the technology. You come to the lab, it works. You deconstruct corn stover or biomass into fuel. We built a facility. We built a pilot plant. We built a demonstration facility. We built a very large scale facility in the American Midwest. And we operated it, and we had to stop. So we did put the money, a lot of it, from a Dupont, but policy was not stable. I mean, every year we were having to look at the renewable credits, what was going to be voted. Was it going to stay consistent? Was it going to go back? How was that going to reflect on the price of dollars per gallon of ethanol? Quite frankly, we were producing in the Midwest, and the most attractive place to sell it was in California, where I live, just because the state of California is very progressive and had lots of incentives. So really the policy fluctuated quite to the point that when the price of oil came down, that backing of the government to continue going through a period of low prices of oil wasn't sufficient to keep it going, right? So I think in short, capital by all means is a huge thing, and you got to have the patience, and you can't be thin of wallet here. It's going to cost. But if you know that the environment will be stable, the policy is there, people are aligned, especially here in the United States, when we have elections, it can really swing from one end to the other policy. That doesn't help because these types of programs, they are longer than any one government term. So I think to me, that's the key issue there is the money can show up, you can find it, but the stability for these types of investments, you need to create it with the policy as well.
Yes, thank you for your answer, Rhys. It reminds me, it was another study, another project I coordinated 12 years ago on the hurdles and enabler of development of biorefinery in Europe and in the world. And the main hurdle, the number one by far, was lack of stability from policy.
Yeah.
And still, nothing has changed. But
nothing has changed.
Your answer give me the opportunity to ask you a question from the attendees. What do you think of the public-private partnership tools? Could it help to accelerate things and development of novel idea, and especially for startup? If Nicolas Sade is still here, that startup has no capital, so no time. So would it be the ideal solution? Maybe Rhys, you can first answer. Or?
I think it'll be very good. And so we are supporting some efforts here to create like a national lab for scale up. We do have national labs that work at the very early stage of research. And I participate in one, Jay Keesing's lab on the advanced biofuels, the J-Bay. But what we see now, companies that have invented interesting things, and they're really stuck in that next stage. So in order to facilitate this, governments are putting the money, and they're bringing academics and industry, and we want that to happen. We want more technologies to flow, because eventually they'll come our way. We may partner with them. So we are seeding them with some of our technology. And this might even be creating or building some demonstration type of facilities or pilot plant type of facilities to help all the companies go to the next stage. So I think that's critical. That's missing. It's required. And companies like ours and our competitors, we will support it. I have lots of discussions about what types of open source technology we could come up with. can we put some of our technology in the hands of these institutes, so they really take off? So it's an interesting time. And I think these types of partnerships, they definitely have to happen.
Okay, thanks. Sorry, I had to unmute.
So, Christophe, maybe if I can take your question as well. I think it's one of the main possibility for small companies to be financed. When you start to your own company, you have to develop your process, even if at the end you want to do a molecule which already exists, but as a petro-based drop-in molecule, you need to create your process at one point. It takes a lot of time, and I think I join you, Christophe, on that. The stability of the capital and the financing is a good. It's very important as well for a startup to grow and be able to work on partnership on long term. Getting access to this capital privately on the private way, it's not so easy. At FUN, we have made successful one of financing with friends and family, and also after a couple of institutional, with one first round on where we raised 2 million, and after 22. But at the end, partnership on the help of, as in Europe, the BBI-JU, for example, is really, really helpful for companies to be able to move forward. So I guess, yeah, it's clearly one of the key for the finance for small companies.
Thank you very much. I think we only have a minute or two, so we need to finish off this session. And at the end, I think we have Christine Lang or Mary Maxon in this room. So if you would like to say something at the end, please unmute yourself, switch on your camera, if that's okay.
Hello from California. Thank you, Yoshi. Mary Maxon here. I would like to say thank you so much for a terrific breakout. Lots of great ideas. I love the idea of a national lab. Thank you very much, Luis, for the national lab for scale up and pilot plants, and that big companies would support that. The question about public-private partnerships. And thank you, Yoshi, for your leadership. I very much appreciate terrific breakout and terrific session. Thank you.
Yeah. Same for me, greetings from Berlin, and I'm very happy to hear what has been reported in the breakout session, also in the workshop. And thanks for answering my question on the private-public partnerships. We see them as very important in Germany, or in Europe, in Germany, but it seems they are also important worldwide. So thank you very much, Yoshi and Christophe, for organizing this.
Okay, thank you very much. So it's time. So I think our conclusion here is partnership at any level and all level to be pushed for not only for the project itself, but for the finance as well. So I think we can report that to the main room. So let us close this session and get back to the big blue button. Thank you very much all for coming here. Bye then.
Thank you.
Thank you very much.
Thank you.
Thank you. See you soon.
Yeah.
Okay. Yes.
Okay, yeah, let's get back to the other room. Would you like to say something at the main room?
Yes, as the main room, I have to
I think we have to close here.
Yes, we have to close here.
Yeah, well, get out, at least get.
I think, Marcel, that might be about everyone from our session as well. So I suggest also in interest of time, we proceed. And I think first up would be the wrap up, a little report of what has been discussed in the finance and investment session. See if
Christophe,
I can.
would you like to go ahead?
session. It was a short session, but very interesting, with the opinion of two large companies, Dupont and Mitsubishi Chemicals, and the startup Afiren. All the speakers agree that it was challenging, of course, to finance bio-based innovation in this risky world because of a lot of reasons that we'll have no time to describe. But and especially the risk was higher for breakthrough innovation. It means that when you have brand new process, because and how the question was how to de-risk. We agreed on at least many points, but three main points. First, you have to think long term. A breakthrough innovation needs time to enter the market. And we see that in the presentation this morning. And Dupont, it was 17 years. 17 years with a lot of capital behind and a large company. So you can imagine with a medium size of startup. The second also is cooperation along the value chain, and especially with a feedstock supplier. And Dupont mentioned the cooperation with a corn supplier. And three, cooperation with startup. And we all the speaker agreed from the startup side with Afiren, but also from the large company. The trend is in bio-based industry is like what happened in biotech, in medical biotech, in medicine, in health, is that breakthrough innovation are bought by startups, and the cooperation and long-term cooperation with startup is key for all partners, and which is contradictory with with a long-term perspective, and but we all speakers agree that enabling tool to de-risk and to accelerate the investment in bio-based operation would be the public-private partnership. That's the one we have in Europe with BBI, which give a lot of great example. And remember that in this morning we have three panelists, three speakers who benefits from BBI grant for first commercial unit: Advancium, Afiren, and Circa. Okay, and that will be the main conclusion of this breakout session.
Thank you, Christophe. So back to you, Tatiana. I don't have anything to add.
Okay, thank you very much, Christophe. I would then hand over to Marcel for his report from the session on market and development. Marcel, please.
Tatiana, thank you so much. Well, time is moving fast when you're having fun, and that was especially in our session. Time moved very quickly. We had 2 or 3 rounds and among the panelists, and time for 2 Slidos, of which one was an icebreaker. So you can imagine how fast time was going. One of the first questions was how does success look like, and how is it measured? Well, and I must say that there was a pretty common view on that, getting to commercial scale as quickly as possible. Value and volume, and yes, there is a premium for bio-based products, so that was an important statement as well. Get market pull, especially from brand owners, and regulations are helping here definitely. So that is typically what we see also in Europe, where there are strict regulations on a recycled product, is typically moving the market in a certain direction. We also noticed, of course, that in the presentations of this morning, there were 3 BBI flagships granted, and that's also an important factor what is helping you. Another question was, what are the main challenges in bringing new drop-in or bio-based products to the markets? And here we see typically timeframes. Also, Christophe, what you mentioned, that you must have patience for a long time. Well, that was definitely confirmed in our group. Bringing new polymers to the market, at least 10 years, even a big or small company, it still takes you a lot of time. And for small companies, it takes you even longer time. We know the story of PLA, who for NatureWorks, it took them about 25 years before they were commercially successful. And having a competitor helps you also, that you are not the only supplier. Not only for polymers, but also for other products, like Lanzatech also said that 10 years is definitely a minimum. And it helps you if you can sell your product in high-value niche markets. It helps you by crossing the value of death, and it's an important step to larger volumes. Bringing new polymers to the market is very difficult, especially also if your customers need to do additional investments to convert the polymer. So there we see very big challenges, and then bringing solvents to market or intermediates can be easier and can have shorter time frames. As last remark, it was said, definitely be bold, be persistent, and not only save the planet, but save those who are living on it. Tatjana, you have anything to add?
Thank you very much, Marcel. And thank you, Christophe, for these reports from the 2 breakout sessions. I think we're coming to the end of the entire workshop. It has been a really interesting morning for me, and it's well worth getting up early for. Unfortunately, we haven't managed to solve all the questions that we had, but I think all the speakers have presented different ideas, different ways of looking at it. And overall, there seems to be agreement on many things. It seems to be agreement that getting to scale is really the challenge we're facing, that regulations can help, and that this is for many different reasons and aspects. One interesting comment I read from the audience was that success, which is defined by reaching industrial scale and also by your consumers, is, however, also can be seen on a different level of sustainability and carbon neutrality. And I think that then ties in back to the SDGs, and it ties back into what we're doing at something like the Global Bioeconomy Summit. Marcel summed up what Babette and also Sarah have said, that persistence and patience will pay off, and that ultimately this is for saving the species. So it is a game that's well worth playing and well worth pursuing it together to reach the milestones that we all want to see. With this, I'm actually at the end of what I want to say here. I would like to hand over first to Yoshi and then to Sarah for the closing remarks. I would invite all of you to stay in contact via the different contact details that you will see in the final presentations. I'm also being told there's a WonderMe room which you can enter afterwards, or you can contact us via the GBS platform if there's any questions that haven't been answered yet, or any comments you really feel you want to bring to our attention to include in the final report. So now finally shut up. Yoshi, it's over to you, please.
Yes, thank you very much, Tatjana. I think we had a really wonderful session, and I think this Global Bioeconomy Summit is the place to exchange information and then reflect such idea to the plenary session, and then eventually the entire GBS comment is going to be the vehicle to transfer our message to the world. And so I think it was my great pleasure to be able to be involved in this session, and I thank you all for the participation, and especially for Tatiana and Sarah. Your managements were excellent. Thank you very much. So now to Sarah.
Thank you, Yoshi. I mean, as we hit 9:30, which is the close of our workshop, indeed, thank you to everybody. We've said so much that has relevance to scaling up and embracing the bioeconomy. So let's close with thinking that, you know, we have a bioeconomy muscle. It's time to flex it. And the rest of the world is open for us to flex that muscle. We can afford to be bold because there's an urgency to the solutions that we offer. And that's what we do right from the lab. But you know what? If a solution stays in the lab or it stays at small scale, then it's not really a solution, is it? It's simply R&D. And we're in the business of creating solutions fit for the world. So let's break free of thinking in terms of petroleum, a petroleum, if you like, thought cage, and instead truly embrace a vision that's not dictated by the past, but embraces the future and all of those trends that I kicked things off with. Thank you. And we really look forward, as Tatiana said, to carrying on this conversation.
Thank you so much.
Okay, thank you very much. I think that closes our workshop very nicely. So
Yes,
have a
indeed.
nice day, one and all. Thank you.
Thank you. Bye-bye.